Right, hi guys, welcome to another video in which I try to teach you something about ProjectKorra add-ons. In this video we're going to be taking a look at making blast moves, and we're going to be doing that by making a move called Air Vortex, which is basically, will be just a move on which you left click, and when you do that a burst of air shoots out from your location into the direction you're looking, slightly damaging any enemies it collides with and pushing them away. So yeah, that's what we're going to be doing. To achieve that, we're going to be taking a look at a couple of concepts. It's going to be locations. We're going to take a look at locations. We're going to take a look at vectors, specifically in the context of Minecraft, because vectors are a very, very big thing. We're going to be gathering all the enemies around a certain location and apply movement and damage to them, as well as extinguish them in case they're on fire, because it's air. Okay, so let's get started. I've already created a project for it right here. In this video I am not going to go over to Eclipse anymore, because I've showed the necessary actions for like exporting, importing libraries, creating a project, stuff like that in a previous video. So if you need a refresher on how to do it all in Eclipse, just skip back to that video real quick. Link to it will be in the description. Alright, Air Vortex. So let's go ahead and make our packages. I'm doing it again. Let's do that in the source folder. me.finbueno.airVortex. Alright, and let's go ahead and create our main class, Air Vortex. Now, things like extending air ability and implementing add-on ability, I won't be explaining those again, because again, I've went over it in the previous video, so I'm not going in depth on that again. So we're going to extend air ability and then implement add-on ability. And now that we've done that, wait, let's first import air ability. And we've done that, we implement the necessary methods as well as our constructor, and we call the super constructor there. Now that's great. Let's just go ahead and do this. A move that blasts away any enemies in your path. Great, that's cool. All right. The reason I'm making, I chose to make something like Air Vortex is because I want to use this move in the third video as well. Because in the third video, I want to demonstrate how you make special kind of particle effects for your moves. You can create cool shapes and then rotate them along with where the player is looking, because that's where most people kind of fail, or well, don't know how to progress, because they've managed to make some cool like DNA like effect or some cool star or whatever, and then they want to rotate it along with the player's view, and that's usually where people get stuck. Alright, so let's go ahead and fill in this necessary bits of information real quick. The author, the version number, and where's the name? Oh, here's the name. Oh wait, last time I obviously did that myself. So let's go ahead and say Air Vortex, and let's plop it down here. There's absolutely no need to throw it down there. Let me just quit my Discord real quick, because I got a message and I thought I muted my messages. I did. I guess the sound just still popped up. It's not harmless, so let's leave that false, because we're going to be damaging people, and it's not a sneak ability, because it will just be left click. Then there's going to be a cooldown. Let's set it to a 2000 milliseconds cooldown. In this video, I'm also not going to be showing configuration, how to set configuration values yet, because I know that there's someone in the Discord server who's made a kind of like utility plugin to make that easier, and I want to look in that a little bit first. So that I can give an example of using that, because I personally hate setting configuration values manually, because it opens up a whole lot of bugs, and it's just a gateway to odd and weird bugs. So I prefer to recommend you a way to do it manually. I will still show you how to do it manually, but I want to recommend and give you a way to not do it manually. Alright, so get location we can't fill in yet because we want to pass the location of our blast and we haven't made that yet. And then we come to load and stop. Alright, so let's go ahead and initialize a listener that we haven't created yet. So vortex listener, we go here and let's go ahead and create a field, and it's going to understand, alright, vortex listener, I see that, it just doesn't exist yet. And let's actually just go ahead and create that. And we're gonna implement listener in there because this is in fact a listener. And we're gonna come back to this. Oh wait, what the hell are you doing? Why is it not? Come on, please. I just want. Yeah, okay, there you go. No, I just want. Okay, you know what? I'm gonna get back to that later. I can't be bothered. Okay, let's go ahead and create a permission, like bending ability vortex. Now you might be wondering what happens if you don't create a permission and you check for one. Actually, it's pretty funny. Nothing bad happens. Everything will still work, but in order to create a default for a permission, like this, let me just go and create a field for that real quick. In order to be able to set the default, like OP or false or true or not OP or whatever, you're gonna have to specifically create a permission like this, and then that's it. And then in here, let's go and say handler list unregister all, and then the listener, because we want to stop it when ProjectKorra reloads. And then we say ProjectKorra dot plugin get server get plugin manager, remove permission perm, and I almost forgot to actually register the listener here as well as add the permission. So let's throw that in there, and then here we say register events, and then listener, and register it using a ProjectKorra plugin because we are not making a full plugin. Now, can I now import it? Thank you so much. Alright, we've set up all the basics here, all the boring loading and stopping stuff. And now that we've done that, we're gonna go ahead and create our listener here. So let's throw in an event handler annotation here, because otherwise our listener will be picked up, and say on click player interact event. Alright, so last time I saw that someone in the Discord server of ProjectKorra was a little confused as to the first if statement in this event, and that was, in the previous video, that was get action equals action right click block, yeah, it was right click block. Now this I had in the last video, and I'm gonna explain this real quick, because player interact event, when we go in here, I don't know if there's any documentation. Okay, no, there's not, so this is useless, but we can go here and basically say nah, wait, I don't even really feel like pulling up all that documentation, because I can just explain it. We have player interact event, which is basically an event that fires anytime a player interacts with the world, basically. That's a bit broad, but when we go to action, we see there are 5 entries: left click block, right click block, left click air, right click air, and physical. These are all pretty self-explanatory. This one happens when you left click a block, when you right click a block, when you left click the air, when you right click the air. This one is specific because this one doesn't fire when you're not holding an item, because when you just right click the air without an item and not clicking on a block, your game isn't going to tell the server that you just right clicked. So this one only fires when you hold an item, which is very sad, because that's why we can't really register moves by right clicking, only by left clicking. And then there's physical, and this is stuff like pressure plates and stuff. Now if you were to have like a sneak event, you wouldn't need this at all, because sneak events only fire when you sneak. So you already know you're dealing with the right action. There's no get action method on a sneak event. Sneak event fires right before the player actually toggles their sneak, and it fires on both when you start sneaking and when you stop. So the sneak event has a method called isSneaking, which returns true if the player is about to start sneaking, and return false if the player is about to stop sneaking. So that's what you want to check right there instead of the get action stuff. Now we don't want to check for right click on a block. We want to check for any left click. A left click air is sent to the server regardless if you're holding an item or not, so we can just use that. And we want to use both the left clicks. We want to see if they left click air or a block, and if they did, we're going to continue. But just like last time, we want to invert this if statement so that we can just return if it's false. So what we're checking for now is actually it should be like this. When the action is not left click air and it is also not left click block, return. Stop the code here, we don't want to continue. Alright, now let's continue and grab our player from the event, like event get player, and import that, and then we're gonna grab our bending player, because there are a lot of bending things that we are gonna be asking our code. So the main one is bending player can bend, and then we have to pass a core ability again, which will be our air vortex. So just like last time, we just do it like this. And if this entire if statement passes, we just want to say, alright, new air vortex player. There we go, create a new one. Because can bend, if we just control click on it, we can see its code, I was hoping. Yeah, can bend. So there are a bunch of checks here. If the player is not null, if the ability's location is yeah, okay, so there's ignore cooldowns, there's check for the cooldowns, there's for the binds, if you're in a disabled world, if your bending is toggled, if you're chi blocked, paralyzed, blood bends, a whole lot of stuff. So this can bend method just does most of what we need, which is great. Alright, we finished our listener. We're gonna say suppress unused warning if annotated by event handler. And now we're in here. I'm also going to disable this make package private inspection. There we go. And now we're in here. We want to start the move. Alright, so for our move, we're gonna need a couple things. Our move is going to consist of oh, I see that my microphone is being a bit loud. Let me turn it down a bit. Alright. So, oh, it's still loud. I hope this is better. Okay, so our move is going to consist of mainly two things. It will be a location and a direction, and the direction will be the direction the location needs to move in every tick. So let's go ahead and create a field that holds our location. And then we're also going to create a field that will hold our direction. Now, a direction in Minecraft is defined by the vector class. Now, beware, there's also a Java vector class, and we're going to need the bucket vector class. And we're just going to call that direction. Now, I'm going to explain what a vector is in Minecraft in a bit. But for now, just know that it's a direction. Alright, so when we go in here, we basically just want to start the move. So first off, we're going to define the start of the location. We're basically going to say, okay, this is the first value of the location. And that will be the player's I location. So we say location equals player get I location, and that will return a location object, which is basically 3 numbers and a world. It's not that complicated. Then we're going to set the direction of the blast. This one won't change anymore throughout the ability. Location will, because the location will move. And we're going to say get player, get location, not local, get location, get direction. And this is because a direction is bound to a location. A location in Minecraft can has a direction. It's looking in a certain direction. Now, get location dot get direction basically means get the direction of the location of the player, which is the same as get the direction of the player, because the direction the player is looking in is stored in the player's location. All right, now that we've done that, we can just go ahead and say start. Before we continue, I'm going to define some constants here. I'm gonna say damage. Excuse me. It's just going to be half a heart. Then the range, which will also be a double, just in case. We're gonna say range, which will be 25 blocks. And then the cooldown, just going to define that here because that's good practice, which will be a long. And then I think that's it. So let's actually return this constant in here. All right. So now let's go ahead and quickly explain what a vector is. A vector in the context of Minecraft is basically a direction. A vector is so much more than just a class in Minecraft. They are used in math, in a lot of math, in basically I think most forms of science. They're a very big thing, and usually they are defined as a point relative to another point in a 3D plane, usually usually the center of the plane. So I've pulled up this plotter in order to kind of demonstrate to you. So we've got this 3D plane with the center point here 0, 0, 0, which goes to 1, 1, and 1. And here we are going to add a vector. So a vector is basically just 3 numbers. And these numbers stand for the x-axis, the y-axis, and the z-axis. Now in this graph, this is the x-axis, this is the y one, and this is the z one. In Minecraft, it's different because Minecraft wants to be special. In Minecraft, it's x, z, y. Just keep that in mind, that you have to swap these last 2 numbers because normally it's x, y, z, which would be x, y, and z. And in Minecraft, this one and this one is turned around, but not in numbers. So this will be the height, this will be the depth, and this will be the width. All right. Now, when we just put in 1, 1, and 1, and I'm going to say draw, you will see it has drawn our vector. Now, the plane has changed. We've also gotten negative coordinates now, and you see there's this line drawn out from the center of this plane towards our point, which you can see is 1, 1, 1. Now, this is our vector. This is basically just a line from our center point to basically the point of the vector. Now, this is also why a vector is usually defined as an arrow with magnitude and direction. And if you've seen Despicable Me, you've heard that line before. That's where it comes from. It's literally just a line with a certain magnitude and a direction. And the magnitude of the vector is defined by the size of these numbers. Because if we put in 2, 2, 2 here, and then say, let's just say 1, 1, and 1 on the red one, and then 2, 2, 2 on the blue one. You can see this red one, and then this blue one, which overtakes it. Now, you can't argue with me about the fact that these vectors have the same direction. However, it would be incorrect to say that they're the same vector, because this one is twice as long. So the magnitude or the size of the length of whatever of a vector is determined by the size of the numbers. It's the length of the vector is calculated relatively easily using the Pythagoras theorem. You basically just, I think you've heard of the Pythagoras theorem. You don't have to know how to calculate it, because there are methods for that in the code, so just know that it's a thing. So yeah, this is how you can think of a vector. Basically, it's just you put in a number, and it's basically a direction out of, like, from another point in space. So yeah, that's how you can think of vectors. Now, why do we need one of those, you might ask? Basically, we are going to move our location along our vector every tick in order to make it move forward. So on the first tick, our location will be here, and then the next tick we're going to add our vector to our location, which will make our location move towards the end of our vector. Now, if you think about that for a minute, you might realize that the length of our vector will determine the speed. If we have a vector which is like as long as this blue one, our location is going to move at the speed of the length of this vector. But if we use the red one, it's going to move twice as slow, because every tick the location is going to move this distance. So let's say actually in here we are going to set the direction. Now, the direction from a player location is always normalized. Now, what does normalized mean? Normalized basically means that the direction of our vector doesn't change, but the magnitude is set to 1. And there's actually a method for that. We can say normalize, and by doing that we are going to say, okay, keep the direction of our vector the same, but set its length to 1, which is very useful, because after we've done that we can say multiply, and then let's say 1.8, and by doing this we know for a fact that the length of our vector is now 0.8, because first we normalize it, which means that its length become 1, and 1 times 0.8 is 0.8. So the length of our direction of our vector is now 0.8, and that means that every tick our blast will move 0.8 blocks per tick. Alright, and we can go ahead and remove this normalize, because a direction from a player location is always normalized. Alright, now we can get started with the fun stuff. The progress method, yay! Alright, there's still some boring stuff actually. First we're going to see if our bending player can still bend our move, and if not, we are going to stop the move. We're going to say remove, call the remove method, and then return. Oh, before I forget, in here we also want to apply the cooldown of our ability, because if we do it at the end, you could basically just spam left click and the cooldown won't apply until the first ability, our first blast, has finished. Now that we've created a location here, we can go ahead and return that in the getLocation method. Alright, now we've checked if the player can still bend our move, and if not, we remove the move. Now we can safely assume that we can just progress our ability. So first off, we are going to check if our location has hit a block. So we're going to say location get the block, and get block is going to return a block object, which basically represents a block in the world, and a block has a type, which is an enumeration, a material, and on that material enumeration there's a isSolid method. Now this only returns true if the material of the block is a solid one, like wood, log, stone, stuff like that. And if so, we've hit a wall, and therefore we want to stop our ability, because we do not want it to go through walls. Alright, now at this point we might want to look for any targets that we might have come across with our blast, and if so, we want to just basically throw them in the direction of our blast. So for that I'm going to create a new method, and I'm going to call that method affect targets, and I'm going to just create that here, and we will fill it in later. For now we're just going to leave it empty. Say affect targets, and then we want to place some particles. at our location, and a special method for that because, as you might know, the air bending particles are configurable because there's not everyone agrees on what the best particle is. So for that, there's a special method, play air bending particles, which again is part of the air ability class, which is provided to us. And because we're extending air ability, we can use those methods freely directly in our class. Alright, so first off, we need to specify where we want our particles to appear, then how many. So let's go with like 8, and let's give it more offset than in our previous video. So let's go a bit wild, and I think let's just go with 4 then. I think that's it. Yeah. Alright, now this method is going to look into the configuration file, see which air bending particle has been configured to be used, and then just play that one. Which is perfect, it's exactly what we want. And then we finally we are going to move our location. So we've come at the end, we've done everything, the move should not be stopped, and we found out that the move should not be stopped, and now we are going to move our location forward. It's very simple. We just grab our location, we say add, so add something to it, and then our direction, and that's it. We've now moved our location along our direction. Now we don't need to update the direction because as I said, the direction is the vector is just a direction relative to a given point. So we can just the direction doesn't change. It's still the same. No matter where our location is, we can always add our direction because the direction is always relative to our point. So no matter where we move it, direction we can always just add it. Now there's another check that we need to make here, one that I forgot. We need to check if the move has exceeded its maximum range. Now there are 2 ways how we can do this, and it kind of depends on your ability. If you are making an ability that launches from a source location and that's it, there's a very simple way to track how far the ability has traveled. Now, if you are making something that has to stay attached to its caster, like the person that started it, like some kind of cable or something, you want to check the actual distance between the player and your ability. But since there is no attachment between our player and the move itself, we are just going to keep track of how far the move has traveled. So to do that, I'm going to go up here and create a double variable and call it distance traveled. And in here, I'm going to initialize that to 0. Now, a double is by default initialized to 0. But just for readability's sake, I'm going to say initialize it as 0 here. Now, what we're going to do here is we're going to say if distance traveled is larger than range, then we want to remove and return. And then after we've added direction to our location, we're going to say distance traveled, add, and then direction dot, length. Now we've add length method basically just returns the length of our vector as a double, and we just add that to the distance traveled, so that if we ever edit this number, we want it to move slower or faster, it'll automatically correctly change the distance traveled tracker. Alright, now that's all cool, and in case you want to do this differently, like you need to track the actual distance between the caster and your ability, you can do this. Distance traveled, no, not like that, sorry. Location.distance, and then player get I location, because this will always return the actual location of the player's eye, and not not at the time of the start of the ability. And then we check if that distance is greater than our range, then we do our removing stuff. Now, before some people start yelling at me, the distance method is a bit heavy, because if we take a look at it, we see that it uses math.square root, and square root is a little bit of a heavy thing to call every 20 seconds. I'm not saying that you will really notice it, but just to be nice, it's better to use distance squared, which basically is the Pythagoras theorem without all the square root stuff. And it's much better to just compare that to the power to our range to the power of 2, because it's basically the same. It's just basic math. We take away the square root here, and then we do the same here, so that becomes range times range. But even better is just having a double variable and tracking that. This is the most efficient method. Alright, now all that's left to do is to just create the affect targets method. So in order to do that, we first need to gather all the entities around our blast. So fortunately for that, there's a method in general methods for that. We can say get entities around point. Now our point is our location, and now here it expects a double, which is basically the size of our hitbox. So let's go ahead and just say 1. And oh, I'm sorry, and this returns a list. Now I think we can do this. Now okay, let's say list entity targets. Yeah. Okay, so we've created a variable here of the type list, and I'm not sure everyone's familiar with what lists are, so I'm just going to explain it. It's basically a collection or a container of whatever of a bunch of objects, and all those objects must either be an entity or some subtype of entity, so a class that extends entity. Now we can loop through this list. So I can say for, and there we go, target. Now what we're first going to do is we're going to check if target is not an instance of a living entity. No, I'm sorry, that's not the first thing we're going to do. The first thing we're going to do is we're going to check if the unique ID of the target is the same as our player's unique ID, because if it is, then we're currently dealing with the person that created this move, and if it is, we don't want to do anything, because we obviously don't want the move to move the player itself or damage the player itself. So we say continue, and that's slightly different from return, because if we were to type return here, the entire method would stop, but this time we just want the current iteration of the for loop to stop. In case you want to stop the entire for loop but not the method, you could do break, but we just want this iteration to stop. Now we've assured that we're not dealing with the player that created this move, and now that we've done that, we can go ahead and set the velocity of this target. So we can say target.set velocity, and for now we're just going to do set their velocity to the direction of the blast, which means they will get shot into the direction of our move. Now if you want to damage them, there should be a very simple set damage method on the target. However, there's not, because target is of type entity, and damage can only be applied to living entities, because an entity can also be like an item. And we do want to move items when our move comes across them, but not damage them, because you can't damage an item, not an entity item at least. So we are going to say if target is an instance of living entity, and in that case we're going to say living entity is target. Now it's going to complain. You can't just say there's a living entity variable which is equal to target, because target is an entity and we're not sure that it's a living entity. So in that case we're going to tell it to shut up by saying cast it to a living entity. And that's just basically going to tell Java, alright, I know target is an entity type, I know you think it's just an entity, but I know it's a living entity, so just change its type. Alright, just go do that. And we know that it is because we just checked it. And if we just throw this out here, then I think Java should warn us. Okay, it doesn't. It doesn't warn us. That's pretty bad. Always make sure that when you're gonna cast, you've checked beforehand if it's actually that type. Always make sure. Alright, now that we've done that, we can go ahead and damage it. And I think there's actually a special way to damage in ProjectKorra. Yes, there's the damage handler class, and it has the damage entity method. And in there, we are just going to say, alright. Oh wait, I think actually, now that I look at it, yeah, let me just go ahead and go in here. Yeah, okay. Alright. We don't need all this living entity crap, fortunately, because ProjectKorra handles it for us. That's great. I never knew that. I just learned that. We say the damage handler from ProjectKorra, and then we do damage entity. Now, the damage handler in ProjectKorra does a lot of stuff for us. It handles no cheat plus kind of stuff. So, your move won't be triggered by anti-cheats. It handles shoots a death event in case your move kills something. It I think it also handles armor stuff, so it sees if armor should be ignored or not. And it tracks statistics. So that's all pretty cool. And that's why you should definitely use damage entity instead of the normal damage method from bucket or spigot, whatever you want to call it. So first we throw in the entity, and then we're gonna throw in the damage, which we want it to be, we defined in a constant, and then we throw in the move that caused this. Now from there are multiple variants of this method. There's also one with a player and damage and ability, and then finally there's one with the person or the entity that should receive damage, the player that caused it, the amount of damage, which ability caused it, and whether or not armor should be ignored. Alright, now finally we're gonna say target set set fire ticks to 0, which basically means that set the amount of ticks that the player should be on fire for to 0. Alright, and I think that's pretty much it actually. So what we've just done is we've created a listener, which basically listens if the player left clicked, and if so, it's going to create an air vortex class, which is going to store the initial location and direction of the move, going to set the length of that direction as well as how far we've traveled, set that to 0, add a cooldown, then start it, check if the player cannot bend anymore, if so, stop the move. If we hit a solid block, stop the move. If we've exceeded the range of our move, stop it as well. Then we're going to affect the targets. We're going to play airbending particles. And finally, we're going to move the location forward and update the distance traveled. Before I forget, let's also add play airbending sound at our location. Now, there's a thing with this, because this will play the airbending sound 20 times a second, which is going to absolutely just ravage your ears. You don't want that. So what we're going to do is we're going to only play it every now and then by using a random object, which is going to give us a random number between 1 and like 6, and every time that the number comes out as 0, we want to play the move. So what we're going to do is we're going to say what's it again, threat local random dot current, and then say next int 6, and when that's equal to 0, then play the sound. Now what thread local random dot current does, it basically returns a random object, not a random object, but an object of the random class, and it always returns the same one. Now if you go ahead, and random objects are a bit expensive to construct, so arguably you could create a static final variant here as well, but there's one available from Java, so let's just use that one. All right, and then we say generate an integer with a maximum of 6, so between 0 and 6. 0 is inclusive, 6 is exclusive, so it's going to be either 0, 1, 2, 3, or 5, and then if that number is equal to 0, play the airbending sound. Alright, that should be it. Let's go ahead and create an artifact, because I haven't done that yet, just realized. So go ahead and say jar empty, throw the compile output in there, and say call it air vortex, and then we are going to say build artifacts and build. There we go. Now I am going to stop my server. There we go. And it has completed. I am going to open up my plugins folder, my ProjectKorra and abilities. Here we go. And then artifacts, air vortex, here it is. Open that in the Explorer. Let's see if it could open. Thank you very much. Let's cut that out, throw it in here, and we are going to restart the server. Now, while we wait for that, I would like to explain what my plans are for the next video and why I want to use this move again. What I want to do in the next video is just rework this move a little bit to, instead of just randomly playing air particles, I wanted to display a kind of like DNA twisting effect. And the point about doing that is not to just show you how to make that kind of effect, but also to show you how you can rotate any kind of effect, just literally any effect that you make, along with where a player is looking. So yeah, that video should be up pretty soon after this one. Shouldn't be too much time in between, and I'm saying that now, and I hope to make that true. So I think we can join. Actually, let's see if we can display the air moves in here. And there it is, air vortex. All right. I hope the Minecraft sounds aren't as loud this time. Or if there's any, I hope there's none. All right. So first, I'm gonna make myself an airbender, and I hope the world will load soon, so my lag will be gone. Okay, I've made myself an airbender, and I'm just gonna say bending bind air vortex. All right, we've bound it. Let's left click. All right. It goes on cooldown, but that's it, and nothing happens. All right. Let's go ahead and see what's happening. So first off, we're checking if the player can still bend this move. And alright, I instantly found it. Okay, so what we're doing, we're in the constructor, we're setting the cooldown. And in here, right after that, first thing in the progress method, we're checking if the player can bend it. Of course it can't, because we just put it on cooldown. So what we need to do is we need to say, can bend ignore cooldowns, because we don't want to look at the cooldowns. Now, arguably, there's another thing that we need to add, because what if I were to shoot out this move and then quickly swap to, let's say, air shield to defend myself from an incoming attack, or air swipe to shoot out another attack. The air vortex would cancel because we don't have air vortex bound anymore, though I don't think that's right, because we've already shot the move. After that, it's on its own. We're not doing anything with it anymore, so I think we should be using can bend ignore binds and cooldowns like this. Alright, so I'm just going to build it again, going to stop the server, and wait for it to finish. Thank you so much. See if, can I do it from here? I can. Oh, okay, that's great. Please just continue. Try again. The server stopped. What are you waiting for? Try again. Okay, there we go. And we're going to start the server again. Alright, ProjectKorra started, joining the world, loading, and of course we're going to be dealing with a little bit of lag again, I think. No, okay, the world is still loading properly. Alright, let's go ahead and try again. There we go. We left click and a blast of air shoots out. Let's see how far it goes. Is that 25 blocks? Yeah, I guess it is. Alright. So yeah, we left click, shoots out a blast of air particles, and yeah, that's it. Now let's go ahead and try that on this sheep and see what happens. Alright, so the sheep gets damaged, and he didn't really get pushed, and I think it's because he was standing behind a block, but I'm not sure, so let's try again. Wait, can you please just not go there? I would really appreciate it. Let me close this off so nobody will fall in. Alright, let's try again. Oh, he's definitely getting pushed. Alright, so I've noticed another little problem here, which is that basically the sheep gets pushed along by the air vortex, and then he gets damaged, and then on the next tick he is still near the blast and therefore gets damaged again, and that's probably in your own move not what you want. So let's go ahead and make sure that that doesn't happen. Now, I am fine with them being dragged along and being pushed multiple times, but I don't want them to get damaged multiple times. So for that, we're actually going to use a list ourselves. What we're going to do is we are going to say private, we're actually going to create a set, and in there we will say, we're going to say it's a set of entities, and then let's call it hurt. Let's call it hurt entities. And we're going to initialize hurt as an empty hash set. Now, the difference between a list and a set, a list is a collection that keeps all its contents sorted. So a list, you know, item number 1 will always be this item, and item number 2 will always be that item. But a set doesn't do that. A set doesn't care about order, and it basically just throws order out the window. And the trade-off that it makes for that is that it can be a little faster in lookups and whatever. So that's why I prefer to use a set here, because this collection, this set, will keep track of all the enemies, of all the entities that we've already hurt with this move. So yeah. And that's why I prefer to use a set here. So what we're going to do is when we after we've damaged it, we basically just want to say hurt add entity. Now this doesn't do anything on its own. What we also need to do is we need to check if hurt is already contains this target, and if it does, then we don't want to do anything. So we only want to hurt this target if our hurt list, or our hurt set, excuse me, does not contain the current target. Now, we don't throw the set fire ticks in there or the set velocity, because when a target gets ignited during the move, we don't just want to extinguish them once. The air is still coming, is still shooting past them, so we still want to extinguish them, and we also want to continue to drag them along. Now, it's proper practice to clean this set and just empty it when the move is done. So to do that, we are going to overwrite a method. Now, what that means is basically the remove method is already defined in AirAbility or some parent class of that, whatever. And what we're saying is, okay, don't use that remove method, use the one I create here. However, the normal remove method does some pretty important stuff, like unregistering the move after it's been stopped and stuff like that. So we still want to use the actual remove method. So we're just going to call that here and say super.remove, which basically calls the actual remove method. And then after we've done that, we're going to apply some additional logic, which is just hurt.clear, which clears the list. It's not absolutely necessary, but it's good practice. You should just clean up your stuff once you're done with it, basically. Alright, so now that we've done that, we are going to build artifact again, say air vortex. There we go. I'm going to stop this server, and I'll see you guys in a bit. Alright, so we're back in the world, and let's try our hopefully final version of air vortex. Let's go. There we go. Okay, that all still looks pretty good. Now let's try to blast the sheep. Right, so it got hurt once, but it does get dragged along with the blast, which is exactly what we want. It gets dragged all the way with it, and if we were to just destroy this and then left click, the sheep is going to be blasted into the water, and it almost got carried to the other side. Water isn't considered a solid block, so that's why I can just cast it underwater. I think I can just cast it through here as... Oh no, that's considered full. That's considered solid. Alright, so yeah, that's basically it. This is your intro to blast moves. Thanks so much for watching. There's one thing I still want to explain. Let's go ahead and grab a sheep. That's a cow. I want a sheep specifically. I don't know why. As you can see, you might think that dragging an entity along like that just completely is a bit much, especially because I can now just do this. This may be a bit weird. I can just drag it up all like that and it drop down. Now it drops in the water, so it doesn't matter, but if I do it a bit like on an angle like this, it's gonna receive a lot of fall damage and then just die. If you just want to blast it along once, there's something you can do. I want to show it real quick. You can add set velocity to the hurt list, basically. So you only set the velocity once, and that would be when you first encounter this entity, because after that's going to be thrown in the list, and then this code won't run for it anymore. So this code will only run for it once. Now, if you think that a direction of 0.8 is not enough, you can normalize and multiply this, and then just put in whatever you want, like 2 or 3 or 1 or 1.5, whatever. But keep in mind that normalizing and multiplying this direction, this vector, will directly modify it, and this is also the vector that the location uses to move forward. So if you change the length of this, the speed of the move will also be changed. So in order to avoid that, you can go ahead and say clone, which will basically just create a copy of this direction, and then you can do freely with it whatever you want, because it won't affect the original one. I'm not going to demonstrate that now. I'm just telling you that. And if you plan on doing that, you might want to just create a separate variable here and call that knockback, and then set that in here directly, like knockback, say direction, and then clone it, make a new version of it, normalize, and then multiply by, let's say, knockback, like this, and then just define that here, like so, like that. But that's not what I'm going to be doing. I'm just showing you that. That would be the best way in case you want that. Alright, so I think this is where I will end the video. I've demonstrated what I wanted to you in this video, and I hope to see you in the next one, in which I'll try to teach you something about rotating particle effects for your moves. So thanks for watching, and I'll see you next time.